Imagine trying to teach a computer to read a book. And I don't mean just scan the words, but to actually get it, to follow a character's journey, their ups and downs, across thousands of pages. Well, today we're going to look at an AI that was given one of the biggest reading challenges you can think of, Leo Tolstoy's monster of a novel, War and Peace. Okay, let's get into it. And really, that's the big question here, isn't it? Can an AI truly read a book? We're not talking about a fancy search function that can find a character's name. We're talking about understanding themes, seeing how a character changes, and pulling together ideas that are scattered across a massive, massive text. Honestly, for most AI models, that has been a huge wall to climb. And this really gets to the heart of it. Most models are fantastic at keyword searches. You ask it a question, it zips through the text and finds the sentence with the answer. But genuine understanding? That's a whole different ballgame. That's about connecting a little detail on page 50 with something that was said on page 500 and an event way over on page 1200. That right there, that's the missing piece of the puzzle. But what if a model was just built differently, built from the ground up to tackle this exact problem? Well, meet Quenlong L1.5. And this isn't just another language model that they made a little bigger. Nope. This one was specifically designed to do more than just read words. It was designed to reason across them. So how in the world do you teach a machine to think like a literary expert? Well, you might have guessed it. The secret sauce is all in the training. The team behind this model came up with a totally new recipe, one that's laser-focused on this idea of long context reasoning. It all really boils down to 3 key breakthroughs working together. First, you have to give the model really complex challenges. Second, you have to make sure it learns in a stable, steady way. And third, you have to give it something like a digital memory. First up is this idea of multi-step detective work. So instead of feeding it simple questions and answers, they built a system that automatically creates these really tough reasoning puzzles. It forces the model to connect multiple clues from all over a document just to figure out the answer. It's less about find the quote and way more about think it through and draw a conclusion. Second, they tackled a massive technical problem with something that's kind of like cruise control for training. See, when you're training an AI on these enormous, diverse texts, the learning process can get really chaotic, really unstable. So this new algorithm keeps an eye on everything and adjusts the training on the fly, making sure the learning stays smooth and effective. And that brings us to the third big idea, the memory agent. I mean, some documents are just too gigantic for any AI to process all at once. So this system reads a document in pieces, and as it goes, it keeps a compressed summary of the important stuff. It's a lot like how you might jot down notes in the margin of a book to remember what's going on. Okay, all this theory sounds great, but you gotta ask, does it actually work in the real world? To find out, the researchers gave it the final exam, the ultimate test. They fed the model the entire text of Leo Tolstoy's famously long novel, War and Peace. And to give you some perspective on that, we are talking about almost 770,000 tokens. A token is basically a piece of a word. So this is just an immense river of information for the AI to process and understand all at once. And of course, all those tokens make up the entirety of War and Peace. Yep, all 1,400 plus pages of its complicated plot, its deep philosophical arguments, and its huge cast of characters. I mean, that's no small task for a person, let alone a machine. So this was the assignment. And you can see this isn't some simple trivia question. This is a complex analytical essay prompt. To answer this, you have to understand who Pierre is at the beginning, the middle, and the end, and connect these very specific events that are scattered all over the book. This is a true test of comprehension. So, the big moment. How did it do? Did it just spit back a random collection of keywords? Or did it actually deliver something meaningful? Well, the result turned out to be a potential game changer for AI. So what did the researchers think? They described the response with one word: fabulous. The model didn't just list a few events, it actually traced Pierre's entire character arc. It connected his time with the Freemasons, that dramatic duel, and his awful experience as a prisoner, and it explained how each of those moments changed him. In other words, Quenlong read the novel like a seasoned literary scholar would. It went way beyond just matching patterns, and actually delivered insights that required a real synthesized understanding of the whole book. This is what the next step in long context AI is all about. And the numbers totally back this up. Across a whole bunch of different long document tests,
This model showed a 9.9-point average improvement over the old baseline model. That is the previous best-in-class for this kind of thing. And that's not just a tiny step forward, that's a huge leap in what these systems can do.
So look, this is about more than just reading classic novels. This ability to reason across huge amounts of information is a really fundamental skill. It improves the AI's general ability to think. And you can apply it to all sorts of things, like analyzing a 1,000-page financial report or synthesizing dozens of scientific papers to find a breakthrough. It's a foundational step forward.
Which, of course, leaves us with a pretty mind-blowing thought. Reading one huge book is incredible. But what happens when an AI like this can read and connect and reason across entire libraries? What new discoveries are just sitting there, waiting to be found in the mountains of knowledge we've already created?